Welcome to the introduction of OpendTect. OpendTect is a free seismic interpretation software system for interpreting 2D and 3D seismic data. It is supported on the Windows, Linux and Macintosh. OpendTect also is a free software development platform. The software is released with its source code, which is written in C++. But OpendTect also is a system that can be extended with commercial plugins for advanced, often unique processing and interpretation capabilities. These plugins are built by multiple vendors. OpendTect itself is developed, maintained and supported by DGB Earth Sciences. In OpendTect you will find all the tools that you need to do a conventional 2D or 3D seismic interpretation. This means that we support horizon trackers, fault interpretation, time depth conversion, well tie functionality, geobodies, seismic attribute analysis, 2D and 3D viewers, pre-stack viewers, and much more. Basically, everything you expect to find in a seismic interpretation system is available. In addition, we have built links to other open source systems, such as Madagascar for seismic processing and GMT for mapping. Finally, I'd like to mention that OpendTect is also used to interpret non-seismic data and that it is widely used in georadar interpretations. Let's take a look at some real data in OpendTect. Here we have two 3D scenes. The left display shows seismic in two-way time, while the right display shows seismic in depth domain. You can have as many 3D scenes as you need. These scenes are synchronized. I'll now continue with the scene on the left, the one in time, so that we can look at some elements displayed here. I have visualized a horizon, a 3D object, a fault plane, a random line, a couple of volume viewers, a seismic line co-rendered with some attributes, volume rendered attribute, and a few fault sticks. This is an example of a 2D viewer. Any 2D element in the 3D scene can also be viewed in a 2D viewer. Here we are looking at a wiggle display, which we overlay with a texture attribute. If we zoom in, we see the information in more detail. 2D and 3D viewers are synchronized and can be used in combination for horizon tracking. The outer tracker tracks on amplitudes and similarities. OpendTect also supports the analyzing of pre-stack data, including generation of AVO attributes and angle stacks. Pre-stack gathers can be viewed in a 3D scene or in a pre-stack 2D viewer. Horizons can be drawn manually or they can be tracked using a 2 or 3D viewer. Tracking is based on amplitudes as well as similarities. The well time module supports synthetic to seismic matching. It supports calibrating time depth models, extraction of statistic or deterministic wavelets. One of the really strong features of OpendTect is the attribute engine. This allows you to interactively create and evaluate attributes and their parameters. Attributes can be created using math and logic, and you can compute attributes from attributes. Here we are evaluating the results of a spectral decomposition of this target inline. And here we have combined three spectral components with RGB blending to reveal subseismic thickness variations below a maximum flooding surface. Another strong feature is multi-platform distributed computing. Here we are starting a batch job to compute spectral decomposition volumes by running the job on multiple machines. We select the components we want to output, and we select the machines on which to run the job. We add these to our processing list, and if we want to be nice to our colleagues, we run the job after office hours. This is OpendTect's powerful crossplot tool for analyzing attributes from seismic and well data. Here we see a crossplot between two attributes, extracted in a polygon area around an amplitude anomaly. The clouds can be isolated in the crossplot tool, after which the location of the points in the clouds can be visualized in the 3D scene. One cloud is associated with the inner part of the anomaly, while the other cloud represents the outer rim. OpendTect is released under a triple licensing policy. It is freely available under the open source GNU-GPL license, also for commercial work. This license allows you to build your own plugins. To share these, they have to be released as open source products. The commercial license gives you access to exactly the same OpendTect software, but now you get priority support, and you are entitled to buy or lease commercial plugins. Moreover, under the commercial license you can develop your own plugins and release these as commercial plugins, without releasing the source code. The academic license offers free licenses for the commercial plugins, but these can only be used in research and development and for education. The license offers a more liberal release policy for own developments. Academic licenses are restricted to universities only. All commercial plugins are protected by FlexNet license managing software. Since OpendTect adopted a triple license policy in late 2009, the user base has grown exponentially. We now have thousands of open source users, hundreds of commercial users, and thousands of academic users. Nowadays, the software is used throughout the entire spectrum of the geoscience community. We have now come to the end of this presentation. Before we close, it's worth mentioning that there are many more free features available in OpendTect, such as an extensive rock physics library and a 3D volume builder toolkit. If you'd like to learn more about OpendTect, you can download our free self-training course or visit us at www.ggpes.com.